Hello advanced kings in mathematics. So today we are going to look at how we solve differentiation equations using now from first principles. We are finding the derivative from first principles, not just the way we were doing it. Remember in our previous way, we are showing that what we do here, we drop the power, subtract the power minus 1. So we should always be able to get the same answer. So I'm going to work out these four examples and see how we do it. So let's do with example 1. They've said differentiate the following. The first one is x. So what we do, we first let y be equaling to x. So how do we solve this? For us to solve it, we have to get the change. So y plus change in y, are we there? Equals to x plus change in x. This should be always the first step. Y plus change in y equals to x plus change in x. So what we do next is we make the change in y the subject. We leave change in y this side and move this y this side. Remain with change in y equals to x plus change in x minus. Now when you move this y minus y, what is our value of y? Our value of y is x. Are we there? So we remain with change in y equals to now x minus x plus change in x. X minus x is always a 0, so we shall remain this with change in x. Are we there? So at this particular point of time, what we do, we pull this change in x down, so it becomes change in y over change in x is equals to 1. You can see when you cross multiply over 1, you still get this, so you just pull it down, pull the change in x to come down this side. It is still the same thing. So when you reach at this point, you start as this, the assumption as change in x tends to 0, change in y over change in x approximates to dy dx. So we shall remain with our dy dx as a 1. You can see when we solve the other way, we were solving our x and we just said dy dx. We can remember this. If you don't remember, go back to the first video. We drop the power, which is the 1, multiply x times 1 minus 1. So we shall remain with x to the power 0, which is a 1. You can see we get the same answer. Let's try out example 2. They're telling us y is equals to x squared. They want us to solve this from first principles. So what we do, we do the same thing. Y plus change in y equals to this is x plus change in x. Put it in brackets. So what do we remain with here? This is y plus change in y. When we open these brackets, how do we open these brackets? Remember, this is x plus change in x squared. It's the same as x plus change in x times x plus change in x. We do the same thing. Multiply this times this times this. So we have x squared plus x change in x, and also multiply this plus x change in x, and this times this plus change in x squared. So you think, get this, multiply it by the whole of this bracket, get this, also multiply it by the whole of this bracket. So remaining with x squared plus, if you add this, which is 2x change in x, these two, they are the same values, so it comes to x change in x plus change in x squared. So let's come and substitute it in here. So this, when you expand, is 2x squared plus 2x change in x plus change in x squared. So at this particular point, we take the y this side. What remain with? Remain with change in y equals to x squared plus 2x change in x plus change in x squared minus our y, which is x squared. So when these two are subtracted, remain with change in y. This goes with that, remain with 2x change in x plus change in x squared. So at this particular very point in time, you can see what is common. You can pull out change in x, remain with 2x plus change in x. So at this particular point, we do what we did in the other previous question. I pull this down, so it comes change in y over change in x equals to 2x plus change in x. Because if you multiply this times this, you get this times this. So you are factorizing it out. So at this particular point, we come with our assumption as change in y over change in x, as change in x tends as changing x tends to 0, changing y by changing x approximates to dy dx. So our dy dx will be, now we shall have here 2x, changing x has tended to 0, so we don't need to put it here, so remain with only 2x. We can see now, if we use our method that we used last time, dy dx, to prove our answer, we drop this 2 and remain here with x2 minus 1, leaving us with 2. x2 minus 1 is 1. Are we there? So let's go try out a little bit difficult one. Have 3. So when you reach here, remember this is not dy dx. You have to always get the final answer is when you get this and put it into brackets, substitute in the value of y and get it as 2x. Even here in this equation here, it's d dx, substitute in the value of y, which is x equals to 1, unless they give you y is equals to this as their equation, but otherwise you have to conclude. Let's see the next one. The next one, we do the same thing. We first let y be equal to 2x plus 3. We want to differentiate from first principles, so remain with y, not so, plus change in y equals to 2 into x plus change in x plus 3. We are doing the same thing, so remain with change in y. We are taking the y this side. Here it is 2x plus 2, change in x plus 3, minus what? Minus our y. Our y is 2x plus 3. So remain with change in y equaling to 2x plus 2, change in x, and so plus 3 minus here, open the brackets, to x minus 3. This will go with this and this will go with this. So remain with change in y. We shall remain with only 2, change in x. We do the same trick. Change in y, pull this down, change in x equals to 2. At this particular point of time, we say as change in x tends to 0, change in y over change in x approximates to dy dx. So that means our dy dx will be equal to 2. When try out to prove our answer, so you conclude, so dy dx into 2x plus 3 equals to 2. So when you try out to use our method, when you get dy dx, we drop the power, which is a 1, so we remain with 2x to the power 1 minus 1, and the constant is 0. We remain with 2, 1 minus 1 is 0, so we shall remain with the same answer. Let's try to do a little bit a difficult one, which is root of x, where I will end today. So first thing we have said, we let y be equal to root of x. So how are you going to solve this? So we do the same thing, change in y plus y equal to square root of x plus change in x. We are doing, remember, the same thing. So I move this side, so change in y equals square root of x plus change in x minus our y, which is root of x. So we see this, you cannot subtract this because they are all in the square root sign. So there's only one trick we are going to use, and that trick is rationalizing. But this time we are going to rationalize down. Remember, this is over 1, so we are going to rationalize. So what is the conjugate? The conjugate of this, the conjugate of that thing, you can say it is root of x plus change in x. There is just a need to, this sign just changes to a plus. So we have change in y, which is square root of x plus change in x minus root of x, and here we have root of x plus change in x minus root of, so this is now a plus, multiplied by the conjugate up and also multiply it by the denominator down, which is root of x plus change in x plus root of x. This conjugate multiplies the upper one and the downer one. Are we there? So we can see these two, in case you have a value of, remember, difference of two squares, a squared minus b squared, is the same as a minus b, a plus b. So we are going to, we can see now our value of this, so we are going to use this and go back to this. So we can see when we take that back, this becomes x plus root x squared, whereby this is now the a, this now becomes the a, and this becomes the b. This is the a, and this is the b, and it looks like this equation here. So this will be this and this squared. So we are taking this back to this minus root of x squared, and what do we remain with here? This is now root of this one, changes nothing, plus root of x. So at this particular point of time, this goes with this goes with this, so remain with x plus change in x minus x over, remember there is change in y this side, square root of x plus change in x minus, which is a plus root of x. So remain with change in y equals to, this goes with that, remain over change in x over square root of x plus change in x plus root of x. Pull this down, remain with change in y over change in x equals to 1 over square root of x plus change in x plus root of x. So at this particular point we say as change in x tends to 0, change in y over change in x approximates to dy dx. So that means our dy dx is equals to 1 over, this is root of x. Remember this change in x has now turned to 0, so we don't need to put it, plus again here root of x. So how do we add sides? Root of x plus root of x. It's the same as just get root of x and add the coefficients before, which is 1 plus 1. So it will be 2 root of x. And that means our dy dx is equals to 1 over 2 root of x. When we use add, so that means dy dx of root of x is equals to 1 over 2 root of x. So when we try to simplify it in our way of solving it to see if our answer is correct, this is the same as y is the same as x to the root of x, the same as to the power a half. Drop the power, which is a half. This is x, subtract the power minus a 1. So remain with 1 over 2 x to the power negative a half. A half minus 1 is negative a half. So this can be written as 1 over 2. To remove this negative a half, it's the same as putting a half down as the denominator like this, which is the same as 2 root of x. Can see the same answer. Thank you very much.